good. That's the right volume. Okay. All right. So back to Chrome. All right. So anyone who's interested in finding out more about Heartbleed, that's all you need to enter in the search engine. It's just to type in Heartbleed. That's it. I mean, you will find tons of topics, about this, over the past few days. I believe it came out on Monday. Okay, it was publicized on Monday, and today is Thursday already. So you can find a lot of stuff over the past 3 days to assess the damage of this particular bug, and also recommendations of what needs to happen. Intuit, the company that made that TurboTax, actually made a lot of statements about whether their site was compromised or not. I think a lot of websites also do that too. Is to at least let people know whether OpenSSL, the Heartbleed problem, was impacting their websites and their user base or not. All right. Are there any questions about Heartbleed?
Is there a way to look at the certificate of a particular website to see if they're using OpenSSL or not?
I don't think that is possible, but you can test a website to see whether it has that security flaw still open. So there's a website you can do to test it. So if you just type Heartbleed test, and let's see, this is from EFF. It's probably trustworthy.
Right there, the FILI.
This one. Yep. So if you use this website here, which is Filippo, I suppose, filippo.io /heartbleed. You can enter a URL and see if that website is still impacted or not. I can give you one that is still impacted because I personally manage this website and I have not gotten around to do it. caconnects.org. And if it is vulnerable, it will come back and report as such. On the other hand, another website that I'm managing, and this one I plugged on Monday, is Moodle. So if you go to Moodle, it comes back and say seems fixed or unaffected. So it doesn't report back whether it is using OpenSSL, but at least it will tell you whether it's using the flawed version of OpenSSL. So that's one resource that you can use to kind of check, at least on the websites that you frequent, like bank websites and stuff like that. I would say most commercial websites are already updated at this point, so it'd be the smaller websites that may not have been updated already. So are there any questions? I checked on most of the schools servers, and most of those, all of the ones that I checked have been updated already.
It's probably a good idea to teach all your passwords.
Sorry?
Probably not a bad idea to teach all the passwords.
Exactly. It's probably a good idea to change all of your passwords anyway. And as you're changing your password, use the trick that I told you guys. Write it down on a piece of paper or on a little notebook. So this is a good opportunity to see if that approach works for you guys or not. All right. So let's go to Moodle. And I have to ask them to give me a new certificate too, because this is an old certificate, and somebody could have compromised the passwords and whatnot. Maybe my own password is already compromised. Uh-oh. There we go. And here. So we'll go ahead and continue to talk about GPG, and particularly talk about the web of trust aspect of GPG. Okay. So last time, I created a key ring already. I created my private key. So this time we'll talk about, okay, so let's just say that you have a key ring already created. You can use certain commands. Okay, let me just start from the beginning. Okay, change the font size, start from the beginning. GPG is an excellent tool for encryption. Strong encryption is only part of the equation, because just as what I said a little bit earlier, if someone posted, a public key on the web, on the website or somewhere, and claims that, okay, this is the public key of, person A, okay, and you think, okay, if that says so, it must be the public key of person A, then you use that public key to encrypt a message or a document that you intend for person A to read. Thinking that the encrypted version is safe, you post it onto the internet, okay, and say, hey, person A, I got something for you, okay, and you think that since only person A has a private key to unlock that document, then it's okay. It's okay to post it on the website, post it on Facebook, whatever, right? Unfortunately, that particular public key does not belong to person A, okay? It's person B pretending to be person A and post it onto the internet. Now that the document, the encrypted document is public and everybody can see it, person B can now download the document intended for person A, and person B is the one with the private key to unlock the document. So now instead of having person A to have access to the document, now you have person B having access to that document. The root of the problem is you did not double check and make sure that that particular public key does belong to person A and not somebody else. So the first part of Web of Trust talks about, how do you do that? How do you make sure that a particular public key does belong to a particular person? Okay. So what we'll do today, or what I'll do, is I'm going to show you using a just a terminal to kind of show you how to do that. So I'm going to pretend to be a new user. Okay. So I'm going to pretend to be Tom. Okay. So Tom is a user here, and I'm going to use su Tom, so I become Tom at this point, and use GPG generate key to generate the key for this particular user. And I'll just pick a weaker key because it doesn't take as long to generate, because the point is not a stronger key, but to show you what to do to validate that the key does belong to somebody else. So we say yes. Real name is Tom. Okay. Tommy. Okay. All right. So we want to say okay. Move on. Enter passphrase. I don't want to specify a passphrase in this case. And we have to move on and do something else anyway, because otherwise there's not enough entropy to create the new key. All right. So traditionally, the way you establish authenticity or to validate somebody is actually somebody else is to use a centralized authority called a certificate authority, because that organization will use one mean or another to validate and say that, okay, I can see that this is the actual person requesting this certificate, which says, okay, this is that person. Okay. Has anyone tried to do this, personally, try to get a certificate and have one of these certificate authorities to contact you to make sure that you are in fact you? Has anyone done that? Nope. Okay. Well, I have done that, quite a few times, so I can kind of share with you how they do it. And this is okay. It's still complaining, so we'll just we'll do something when we get to that point. Okay, so let's just say that drtag.org, which is one of my domains, needs to get a certificate. Okay, so that when people want to send information or get information from my website in a secure way, they can use that certificate. So what I need to do is I have to create a certificate request to say that, okay, I want to get a certificate, and I will send that request along with payment if it is if it's not free, to a certificate authority like VeriSign and a few other companies. So they will get my money, they will get my request to get a certificate, and from the request of the certificate, they can see that, oh, I can see that you want to get a certificate to validate that you are in fact the administrator of drtag.org. So now the question is, how can they know that I am actually the owner of drtag.org or an administrator of that particular website? Any
Give them your public
guesses?
key.
Well, but they cannot trust my public key. Remember, it's a chicken and egg issue now. Now, one thing they can do is to look at my physical address on the request form and actually come to the physical address and validate and say, okay, are you here at this physical location? But that's going to be very costly. So they don't do that. Instead, what they do is they make the assumption that I will be running my own email server at drtech.org. And they will ask me to submit an email address with the domain of @drtech.org, and they will send me an email and say, okay, reply to this one so that we know that you are actually, you own the website of drtech.org. So when I get that, the email that will ask me to validate, probably with a link, then they will get back a confirmation that the email that they sent to drtech.org did reach me, and I was able to return a reply to that one. And that's usually what they do, especially for either inexpensive or free certificate authorities. Is that secure? How secure is this particular method? In other words, how difficult is it for somebody who does not own the domain name drtech.org to basically spoof, the whole request thing, so that person ended up having a certificate that says, yes, I am drtech.org, but that person really is not me.
So all they need is your email address?
Yep.
And your password.
Say again?
Email address and password, and that all they would need?
To get my signed certificate, or to spoof the email.
To email it to them. I don't see how it would be safe. But what exactly it is security wise. Because if you give the person the server the email address and password, then but they are already posing as a mini.
Well, the process goes like this. I submit the request, and then they will use the email address in the request and match the email first to the domain name, where the certificate will say, okay, this is the organization of that certificate. If it does not match, they will stop right away and say, okay, we cannot do this. So those two have to match, and then what they will do next is to send an email to my email address with the same domain name as the one that I'm requesting a certificate for. And they will send that email message. And when I get that email message, I have to reply to that email message to basically say, yes, I'm here. Go ahead and go through this process. So the question is, is this process safe? Relatively. Okay, so I like that term, relatively. So who can potentially get in the way and basically spoof my original request of, I am Dr. Tech, I want to get a certificate? Because whoever's trying to do the spoofing will also have to intercept the message that was intended to me, because it was sent to drtech.org, or a domain, a subdomain name of that. So who can do that type of spoofing? My neighbor probably cannot do it, but who can do it? It has to be someone who has access to the SMTP server. So when the email is on its way to get to me, that particular organization has to be somewhere along that path and see that I'm requesting a certificate and intercept in between, or somewhere in between, so they can spoof my email address first to generate the request, and then when it comes back as an email address, they can also intercept that message. So I never really get anything from the certificate authority, because it's all intercepted in somewhere in between. So who is along that chain of SMTP servers? My ISP, that's right. Okay, so your ISP actually has a lot of ways. If they have anyone working there who is a black hat, that can be very, very bad, because your ISP actually has a lot of ways to get to your content, especially email, because email tend not to have end-to-end encryption. When you're using HTTPS, then it's okay. You can have as many people, as many hackers in between. It would still be quote-unquote okay, because it's an end-to-end encryption mechanism. But email, on the other hand, is like, there's no encryption whatsoever. Okay.
Is that hard to implement? Why don't they just do that by
Well, you can do SMTPS, or the SMTP over SSL. You can do that. It becomes end-to-end encryption to the target machine. But if your ISP is in between and you don't run your own email server and you just rely on your ISP to relay the message to you, then you still kind of run into the same, similar kind of issue. All right. So let's see if we have enough entropy at this point. Yep, it does. Okay, checking the trust DB. Okay, so you can see from this message here, it has a database just for establishing trust among people who own the keys in your key ring. So I'll explain all of that later. Okay, so now that I have a key, I'm going to export it. Okay, so I will export my key using gpg-export, and I'm going to export all the keys, which I have only one at this point, and I'm going to export everything to the temp folder, and just basically go to the temp folder and make a file called tom.gpg. The other way to specify the output file is to use --output as a switch. So there are several ways to generate a file that is the exported version of your keyring. So I'm just putting this into the temp folder, and the reason why I put it into the temp folder is the temp folder is visible to everybody. Okay, so I can actually get to the temp folder now and see what is over there. Okay, so I can look at the temp folder, tom.gpg. I can actually see the item is over there. I can actually look at it as well. In other words, a text editor is not going to work, so I'm going to do a hex dump on that file just to verify that I can see the content inside that file, gpg. So I can definitely see the content of that file. So what I can do now is I can import that keyring so that my own keyring now has a public key of Tom in my keyring. Okay, so I can do a gpg-import and specify the input to be from that one single file that Tom created. So tom.gpg is the file, and I'm importing it because I have not run gpg gen key myself, so it has some warnings, but that's okay. Okay, it did get imported correctly. But now the question is, okay, I got that gpg file on the internet. Okay, and next to that link to that file, Tom, I see a message saying, from Tom saying, this is my public key. Use it to encrypt documents that you want to send to me in secret. And I'm suspicious. Did Tom actually put that, HTML document up? And did Tom actually generate that particular GPG public key? That's the question that I legitimately should have. Is basically the question, okay, Tom, did you actually, generate this key, or did I download the key of somebody else? Okay, that's the question. Now, how do you double check? How do you know whether that key is really from Tom or not? There's an easy way to do it, but it's extremely tedious and also not realistic. The reason why it's not realistic is like this. Okay, I can do a hex dump, and with that one file that I downloaded, okay, tom.gpg, and then I can call Tom. Oops, oh, forgot about temp folder. Thank you. So I can look at these, hexadecimal digits, and I call Tom up, okay, and I say, Tom, is your public key 019904824753, and I read the entire thing, and then Tom would have to be sitting at his computer checking the file, checking his own export file, and validate everything across the phone. That's one sure way to do it, because if I make a call, unless somebody can impersonate Tom's voice at his phone number, I'm fairly sure that I'm actually talking to Tom. If I cannot even trust that, I can just walk over. If Tom is local enough, I can just walk over, drive over to Tom's house, and actually say, Tom, show me your public key, the hex dump of that file, and I can double check and everything is okay. Well, if I'm really at his place, I might as well just bring my jump drive and say, can you just copy that file onto my thumb drive? Okay. So even though this method is correct, it is not practical because this is a pretty long file. Yep.
Could you just check like the first and the last, is probably good enough?
Well, that's not usually good enough. Unfortunately.
It's like how MP5 something is, you usually check like the first couple of them there, right?
But there is a better way to do it. Okay, there's a better way to do it. The better way to do it is for me to go into GPG, and you can use edit key as a switch. Now, when you specify edit key as a switch, you have to specify whose key do we want to edit. So in this case, it's just Tom, right? So I'll just use Tom, as the name. You can use either his unique ID, his common name, or his email address. So all of those can be used to identify a particular key when you use this particular command. So right now, I got into GPG, and you can see the prompt is no longer the system prompt. It is now GPG and a greater than symbol, which means I'm inside GPG. GPG is running in interactive mode at this point. When GPG is in interactive mode, you can, if you want to, just type help to see what kind of commands you can run when you're in the interactive mode. But one particular command is useful at this point, because what I can do is I can do a fingerprint, and it is FPR. Now FPR, or looking at the fingerprint, is really kind of handy, because instead of reading the entire content of that file, I now only have this many digits to spell out and basically communicate over the phone. So we are talking about 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. We are talking about 10 times 4, or 40 digits, 40 hexadecimal digits, which is certainly doable over over the phone. So this time I can now call up Tom, or call up Tom and say, okay, Tom, what is the primary key fingerprint of your key ring? Is it 233B, D934, and so on? It will only take about 30 seconds, right? Instead of minutes and minutes and minutes. So that's how you can validate a particular key and say, okay, is that really Tom's key? Now, if all match, okay, if after the phone call and I'm convinced that this is actually Tom's key, I probably need to indicate that this key is validated. Okay, that I have established the actual identity of the owner of this particular public key. So at that, yep, go ahead.
Just to be sure, when you did the export, the Tom, you only exported the public, right?
Yes.
Okay. There's no functionality in GPG where you can actually accidentally export your private.
You can do an export private key. There is a switch to do that.
But you actually have to explicitly say that.
Correct.
Okay.
Yeah. If you're dealing with the private key at all, the switch will spell out the private key. You cannot accidentally be exposing something that you do not intend to expose.
Just want to make sure.
Yeah. Well, that's good idea. Good idea. Okay, so what a person normally would do in this case is just to enter the command called sign and then press the enter key. When you sign a key, what you're doing is you're attaching a little bit of a signature next to the key, and you're basically saying, yes, I am TAC and I have validated this particular key, and here's my seal of approval. Okay, so you're basically attaching a seal of approval to this particular key. But I can't really do it now because I don't have my own key pair generated yet, because I'm back to my own account, the default user account. So what I need to do at this point is to generate my own key first. Okay, so we'll go ahead and do a gen key and go through the whole process. Now, by the way, my key doesn't have to have the same specification as Tom's key. Okay, I can have my own specification. Tom can have his own specification. So it's okay to have a different one, but I want to save time, so I'm going to specify a 10,004-bit key here. And I'm just going to say tag. Okay, it wants a longer name. Okay. Enter passphrase. I'm not going to put a passphrase here, and this will take a little while too. So while it is collecting all the entropy, we'll go ahead and look at all these commands. So we have export, and when you're exporting, you can also export only the key of certain people. So you can specify the name after -- export in order to limit what whose key on the key ring you're actually exporting. Because sometimes you may not want to export everything to the file. You just want to export certain key from your key ring to the export file. And here's the import. So basically, I have already illustrated this part here. I have not illustrated how to use -- list keys, but as the name implies, you probably know what that particular switch is going to do. It will list all the keys on your key ring. So it will list the fingerprint of each one. well, maybe not the fingerprint, but it will definitely list the identity of the owner of each key, so that you can see, okay, do I have a key of that person? You can check against this particular command or the output of this command. Okay, are there any questions at this point about how to kind of move keys around, make copies, send it to other people, and add keys to your own key ring? Because what we have done so far is to talk about those mechanisms. Okay, how do you make a copy of your public key, send it to somebody else? How can that person import your key into that key ring? And how can that person double check that it is really your key, and then sign it and say this key is okay to use? Right. So with all that stuff done, okay, these are commands under basically what we have done so far is to use edit key as an interactive mechanism to do something with a particular key on your key ring. FPR, we talked about it already. Sign, we were about to do it, but we couldn't do it because I don't have my own private key to sign it. Remember, when you sign something, you are using your own private key to sign it. Okay, and then other people can use your public key to validate, okay, is this really text signature? And they can use my public key to validate that. What we have not talked about is how to delete a sign. In other words, you are deleting a signature. You're no longer saying that, yes, I validate this is somebody actual key, as opposed to revoke a signature. Revoking a signature is different from deleting a signature, because when you revoke a signature, it leaves behind a log entry to say that Tech, for whatever reason, revoked his signature for this particular key, as opposed to deleting, which is as if I never signed the key to begin with. Okay? Are there any questions about the differences between deleting versus revoking a key? Now, in order to revoke a key, I also need to have my own revoke certificate, which can be generated by GPG. The last one turns out to be the most important one, because you can establish a trust relationship, but not with the key itself, but with the owner or whoever owns that key, whoever issues that key. So let me see if I can, okay, this is all done. Great. So now we can go back in and edit the key from Tom. So I have just called up Tom, and I say, okay, Tom, is your key actually having a fingerprint of these hexadecimal digits? Tom came back and said, yes, I can definitely say that it has those keys. In a real situation, how would you spell out the keys, or how would you arrange the validation process? Are you going to spell out the key and then have Tom to say yes or no, or would you have Tom to say, would you ask Tom and say, Tom, what is the fingerprint of your key? It's the second case, right? Because if you if you spell out your key, even if it really is Tom over the phone on the other side, Tom can be doing something quote unquote important and just go, yeah, that's it. As opposed to if you're asking Tom to spell out the key, then Tom actually has to look up his fingerprint and tell you what it is. So let's just say that at this point, I have validated this key. So I can say sign. This time I have a private key. I can sign it. So here is the question. The public key is Tom's. It's created on a particular date. It does not expire. So it's giving me all the details of the key that I am about to sign. So all of this stuff here, these highlighted lines, tell me all the details about the key that I am about to sign. Basically just making sure that I know what I'm doing, okay? And it is telling me that I am going to sign this key with my own private key, and my private key, it has all this information about myself, okay? This number here, the D9355306, that's actually my unique number associated with me as an owner of a key. So if I press yes and then the enter key, it would actually go ahead and sign the key. So now when I export this particular key ring, if I export Tom's key into a file, that file would actually now start to indicate and say that Tech signed this key from Tom. In other words, it would basically say, I have personally validated that particular key, or whatever I do, I have signed it already. So if I export this key ring to other people, they will know that tech has signed this particular key. Now, whether that other people are trusting me that I would actually do whatever it takes to validate a key that's a subjective thing. Okay, that's a different question. But it is a good question because it is related to trust. Okay, so once you verify or validate the fingerprint of a key, you can now choose how well you trust the issuer, not the key itself, but the issuer. In other words, now I want to say, well, does Tom really know a whole lot about GPG, or is he really just a novice user copying and pasting commands? Now, why is that important? I just called him up and I just validated that he actually generated the key that he sent me, and it should be good. But what about all the other stuff that Tom is sending me in his keyring? So maybe Tom, when he sent me his keyring, it also includes keys of like 20 other people that I also know. Okay, so now the question is, can I trust those keys on Tom's keyring that Tom has personally or otherwise validated that Mary's key is in fact Mary's, Jennifer's key is actually Jennifer's, John's key is actually John's? How well can I trust Tom being able to do that? That is trust. Okay, and you can select one of the many levels of trust. So when I say trust, it does not apply to the key itself, it actually applies to the issuer of the key. So in this case, it applies to Tom in this case. And I can choose one of these options. Well, 5 options really. One is I don't know or won't say. Okay, which basically means, okay, there's no information available to establish a link in the web of trust. 2, I do not trust, which means, okay, anything beyond this point, I cannot trust at all. Okay, so all of the other keys on Tom's keyring, I just ignore those. Okay, because there's no way I can validate and say that yes, Mary's key is actually Mary's. I trust marginally. Now, marginally in this case is actually a very important word, because when you say marginally, it is already starting to qualify something that can establish a web of trust. So this is the minimum level to establish some level of trust. I trust fully, which means if Tom has Mary's key signed in using his own signature, I would say, okay, I can trust that. Okay, and I trust ultimately basically means Tom's key is as good as mine, or his signature is basically as good as mine. All right, so let's take a look at the web of trust, which is down here. And this is the official word from the homepage of GPG. So I'm going to open this up in a new tab, but we'll focus on one particular part of it. So this is the indented part. This is actually quoted from the GPG website. The web of trust. Yep, go ahead.
So when you say you trust someone, you sign it with your own key and make it sure that it was actually you that gave it the stamp.
When you trust somebody, the trust relationship can be exported. But what it is useful for is for this. Okay, I can show you a picture later on because that will basically show you why it is useful.
Oh, no, I know why it's useful. How do you verify that it's you that stamped it, not somebody else?
Oh, okay, I see what you mean. That's a good question. Trust is in a different file, so it's not actually in the keyring file itself. So when you export a keyring, it does not necessarily export the trust relationships. It's actually in a separate file. So that's a good question. How does it know that it is actually me trusting it? I'm assuming that in the representation that I'm trusting these keys or trusting this particular user, that particular representation has its own signature that is signed by my own private key. So that way people with my public key can double check and say that, well, did tech actually say that he trusted this particular user, so it can be validated as well. So it has to be something that is signed with my private key. Yep, that's a good point. Okay, so let's go ahead and read this part here. It can be a little bit confusing, but I think it's okay. It's not too bad. The web of trust allows a more elaborate algorithm to be used to validate the key. In other words, the old way or the the more rigid way is to say you can only validate a key if you have personally double-checked the fingerprint of a particular key. So this is the old way of doing things. Formerly, a key was only considered valid only if you signed it personally. In other words, if I don't sign something and I get it from somebody else, by default it is not validated. But it would use this method, GPG can use this method to imply trust and therefore imply validity of other keys. So if a key is considered valid if it meets two conditions. It is signed by enough valid keys, meaning that I have signed it personally. That goes without saying. If I sign the key personally, it is already valid because I am the one who's signing it. It has been signed by one fully trusted key. Now going back to the command line here, I trust fully. So that means if you trust somebody fully and that person has signed a particular key, it qualifies right away and say that this key is now validated. It's good. Okay? Or it can also be signed by three marginally trusted users. Okay, this is actually not a precise way of saying it, even though it is actually quote unquote correct, because it has been signed by three marginally trusted keys. Should have read it has been signed by the owners or issuers of three. Okay, I take it back. It has been signed by three marginally trusted issuers of keys. That would be the actual proper way to say it. But this is also okay because there's only one issuer per key in most cases. Okay, so that's why when you answer this question here, I trust marginally is actually important because three of those issuers together will qualify a particular key to be valid. If they all say that they trust, if three marginally trusted issuers all sign on a particular key, then that key is valid. Automatically considered valid by GPG. So you have to choose your friends carefully. Okay, or I should say you have to trust your friends carefully, because as much as your friends are friendly and you can actually trust them as persons, do you trust their skills as far as security, signing, and the use of GPG is concerned? That really is the question. It's not whether their personality or characters and whatnot is in question. It is whether they are technically capable of understanding these concepts and assess other people also. Okay, that really is the question. Yep.
So trusting a person that wasn't careful will undermine your own. I guess.
Yes.
Okay.
Yes, it will, because let's say John, okay, is not very technical savvy and like to take shortcuts. Okay, you'll just say yes, okay, without actually reading the question. So when John sent me a key ring with, let's say, a public key of Michael, okay, and John just wanted to get things done quickly and say yes, I signed the key for Michael, so that he can start to use that key, the public key, for encrypting stuff. So when I receive that key ring from John, Michael's key is already signed by John. Now, if I say that I trust John fully, then GPG would not question it at all. GPG would just say that, oh, you want to encrypt something intended for Michael? Sure, no problem, because John said it's okay already, and I trust John fully. So yes, if you establish a trust to someone who actually cannot be trusted as far as assessing the authenticity of somebody else is concerned, then you can end up endangering yourself, because now GPG would say it's okay to use a public key for a particular person when that may not actually be true.
So wouldn't you always want to say you trust them marginally rather than fully?
Or not. You can say you don't trust. Well, but the point of trusting certain people fully is if you actually know those people personally and you know that they can be trusted fully, you can establish validity of keys a lot quicker and a lot easier. So that way you don't have to go through all the trouble yourself to call up all those people and check is the fingerprint of your key this. and then those people would just answer a call, like, this is the 20th phone call I got today, about my keys, fingerprint, because nobody is trusting anybody else, so they all have to go to the source to establish the validity of the key. But by establishing trust, then you can basically minimize the amount of phone calls that you have to do personally to validate the keys that you are importing from somebody else. Are there any questions at this point about the whole thing about trusting? No questions? Okay. Now there's a second condition too. The second condition is actually quite important because it says the path of signed keys leading from K back to your own key is 5 steps or shorter. Okay. In other words, even if it is someone that you trust fully, it cannot be any more than 5 steps over. Now, what does that mean?
Levels on the key ring, the next person down, the next person. You can't have 5, 6 friends deep.
Exactly. So if A trusts B, B trusts C, C trusts D, and so on, you can go all the way up to F, because that would be 5 levels of trusting. Okay. But anywhere beyond that, even if the trust is full, you cannot do it anymore, because it can only let you go up to 5 levels or 5 links deep. Okay, is that part okay? Now, I think when you trust someone ultimately, it means you can go beyond the requirement of only 5 links, because that's I'm thinking that's the only reason. The documentation actually is kind of old. Let me just look at the documentation here, because when you read the documentation, they only have unknown, which is not I don't know or I won't say. I cannot trust that particular issuer. I can marginally trust, I can fully trust, but there's no ultimate here. Okay, so I think ultimate basically means you can bypass that 5-step thing and say that if this person is someone I can trust ultimately, then it's okay even if it is more than 5 steps away. All right, so are there any questions at this point about the whole thing of establishing trust or the web of trust when you use GPG?
I guess I just don't understand the marginal. If you're thinking someone's a little shady, I don't know if I trust them, but you happen to be the third person that does that.
Well, 3 is a crowd. It's basically saying 3 is a crowd. So if 3 marginally trusted people, they all trust a particular key or trust. If they all sign on a particular key, then it's still okay. So you can choose to say whether you cannot trust somebody or you can just trust that someone marginally. And I think that's really a subjective call, and that's the documentation made it very clear. This is very subjective. There's no easy way to gauge, which level you should assign a person to. So it's entirely subjective, and also it also depends on what kind of stuff are you encrypting. If you're encrypting, like just pictures, okay, and stuff that is not particularly really important, you just want to ensure some level of privacy, then it's probably okay to classify more people to be marginally trusted instead of not trusted at all. On the other hand, if you're working for a national lab and you're passing along top level secrets, you probably want to only allow 1 level, okay, or not even trust anyone. Okay, so in that case, you will have to personally walk over to somebody else's cubicle and say, okay, I want to see you actually drag over your public key into my thumb drive. That's the only way you can trust someone, ultimately, if that level of trust is needed. So this is all dependent on what content you're trying to encrypt and what is the context of all the encryption. Are there any other questions? Those are all very good questions. I like those.
That makes it hard to enforce. I feel like if you did that, like people would just not follow your, protocols.
So that's why you have to know whether that person is technical enough, and also whether that person can assess other people as well.
It says ultimate trust only applies to your own keys.
Say again?
It says ultimate trust only applies to your own keys. You can ultimately trust your
okay.
personal keys.
I see. Thank you. But that doesn't make any sense because you are already running GPG as yourself, but it applies ultimate to somebody else's key. Yep.
I think the idea is that you can't ultimately trust anybody but yourself, because you can't ultimately trust that there won't come a time somebody has access to one of your fully trusted friends' accounts.
But it doesn't make any sense because otherwise I should not even have the option of ultimately trusting Tom in this case, because I got Tom's key from a file.
Say you log in from a different computer.
Mm-hmm. Well, let me see if I can use 5 here.
Might as well.
Do you really want to set this key to ultimate trust?
At least it's asking.
All right. Please note that the shown key validity is not necessarily correct unless you restart the program. Okay, unless you restart GPG in this case. Okay, but it did let me establish that trust. So let me see if I can relist that and see if I actually have established that trust. Okay, so we have enable, show, clean, minimize, check. Okay. So check, basically shows UID. This is Tommy, his email address and whatnot, and it has a self signature, and it is also signed by me. But it doesn't show whether I'm signing it or I'm trusting that person. So let's see if there are any other commands that can show that. Check signatures, sign, preference, trust. Well, I know what to do. Make it wider. Let's say check again. Nope. The output is truncating, because of that. Fine. Do again. Check. Nope, still doesn't work. Yep, it does. Well, duh. As soon as I get in, it basically indicated that this key or the issuer of that key is ultimately trusted. But that's not myself. So I think what it means is a ultimately trusted issuer is as good as myself. So anything signed by that particular key is as good as I'm signing it myself. Are there any other questions? No other questions? Well, this sounds like a lot of trouble. Sounds like a lot of work to do. In other words, if you want to establish a web of trust and only using export and import, you'll be doing a lot of importing and exporting. Because what if, let's say, Vincent has updated his key ring from last week, and I want to know, hey, Vincent, what else, are you, who else are you trusting now? I want to get those things imported too. Then Vincent will have to re-export everything, and then I have to re-import everything. Okay. Now, there are ways to automate the entire process, but it is still kind of cumbersome. So it is helpful to be able to export or not export, to send your keys to a key server. So when you want to do that, you want to use send keys as a switch, and you can also optionally use -- key server to select which key server you want to use to maintain the keys. You can run your own key server if you want to, and then there are public ones that you can use for free. So this is an easier way to keep track of your keys, because you can just go to the key server and say, okay, I want to receive a key from this particular identity, and then you can get the public key of that particular identity. So you don't have to keep track of thousands of entries in your own key ring. Yep.
What's the use case of having so many having keys and signing them like that, in terms of just a group of people, say 5 people, I guess, is it just to build transport or encrypt materials?
What is the application of?
Yeah, what would you normally use it for? Would a corporation use it for just authenticating the computer?
You mean GPG in general?
Yeah, what would you use
Debian uses it all the time. Okay, so think about Debian as a distribution of Linux, okay, or any Debian type of distribution. So that applies to Ubuntu. It applies to what else are Debian based? Sorry, Mint. Is Arch Linux also a Debian based? You don't think so?
It's independent, I think.
Is it? Okay, but there are a lot of Debian based distributions, so they all pretty much use the same mechanism. Okay, so let's say I'm the Debian website and I'm responsible to maintain the repositories. Okay, so one of my responsibility is to make sure that people cannot spoof the content of these distribution files. In other words, you guys can copy the deb files all day long if you want to. So somebody is going to download it and go, okay, you want to install this deb file and you want to install that deb file and so on. But ultimately, before you run dpkg and then -i and then the deb file to install the deb file, you might want to double check that that deb file is really coming from the Debian upstream website and not somebody repackaging something into a deb file and say install this, right? Does that make sense? That you might want to establish that authenticity. Okay, so what do? What you do is you look up on the Debian website and say what is the signature for this particular file. Okay, so the signature is basically the same thing that we saw earlier. It's just a short sequence of hexadecimal digits. What do you do with that hexadecimal digits? You have to run the Debian public key against that signature to recover basically a checksum. And then you run your own checksum program on the deb file itself, and they should match. So that's one really useful application as far as Debian is concerned, and that's why all repositories of Debian, they all have key entries in a key ring.
So for package signing, basically.
Right, because you want to establish that these particular packages, these deb files, did come from a particular website or distribution. Yeah, because Debian is not concerned about encrypting the content, because hey, it's all open source. People are supposed to see that anyway. But it is concerned about the authenticity of the file. So this is one way to double check and make sure that the file that you're downloading and installing is in fact the file that the Debian website says it's what it should be. Okay, so that's a good question. In fact, that would be the majority of applications of GPG, and it's not really mostly used for encryption. It's mostly for signing stuff.
Okay, yeah, because I was wondering, it seems a little paradox to me to encrypt everything, but to actually verify and authenticate, then that makes sense.
Well, encryption is useful, especially when you're backing up something. So this is a good time to kind of talk about this. Well, it's an incident that has happened with a certain organization that I will not name. All right. It has to do with how files are backed up on a server. So it's not entirely related to a client computer, but it can happen to a client computer as well. Okay. So what you want to do is to kind of imagine that you have a computer and you want to back it up. And you're not trying to back it up on an external hard drive, you want to back it up to a network resource. Okay. So how many ways do you have to back up something onto a remote resource? Lots. Okay. But the easiest way is to mount the remote resource to a mount point on your local file system, because in that case, it becomes just a folder. Drag, drop, you're done, right? Instead of running all kinds of obscure commands to do it, okay? So what you want to do is to imagine this, okay? So we have a backup server that is dedicated to storing backup files from many, many different sources. Okay, so the backup server backs up machine A, machine B, machine C, machine D, and finally my server. Okay, so here's my server here. All right, so the way I'm going to do my backup as a system administrator is I'm going to mount a particular folder here to a certain mount point on my local file system. Once that mount point is established, I just need a command like cp, right, or tar, so I can create backups of my own file system into a single file over here, which is automatically stored over here. Okay, and this link here is done by Samba. I have to authenticate into the backup server using Samba and say, I'm so and so on this server. This is my password. Can I gain access to this folder on the backup server? That's basically what happens when you try to mount a remote file system locally onto a particular file system. Okay, and this is fairly common even for client computers because it's a very handy way to back up something onto a remote network drive. But there's one problem or several problems with this approach. One is in order to get this mount point to work, I have to know a password, a username, and a password on the backup server itself. Now that by itself is not a really bad exposure, but on the other hand, if the backup server is run by only one person with only one password and one username, that one single username and password would also be able to see all of the backup files coming from A, B, C, and D. Not just my backup files, but all the backup files of everybody else. This particular user can see everything. Am I doing okay so far? Now, which computer do you want? Okay, let's assume that this has to be an automated process. Now, if this is an automated process, which computer has to store the, there's a name for this thing. It's called okay, I'll just use username and password. Okay, which computer has to store the username and password of that particular user on the backup computer? Well, this computer needs to store it, but so this computer has to store it too, because otherwise there's no way to remotely mount this system onto here. Because the login direction is logging into the backup server from the local machine, from the client machine. Okay, so that means the exposure is now suddenly very, very bad because I am now exposing the username and password of an account on the backup server itself, and it is now locally stored. Is that okay so far? Okay, so in this case, what happened was a particular script was written to do the remote mounting. Okay, and then in the script itself, somebody was using a dash. They were using a switch on the command line to specify the username and the password, and that is a big, big, big no-no. Okay, the reason why that's a big no-no is when you use PS, certain options or switches of PS can expose the entire command line with all the switches and everything. So if you specify the username and password as a part of a command line, PS can show that. And there's no protection, okay? An end user can run PS with those switches and see the entire command line of everybody, including root. So you do not want to ever specify a password and username on the command line itself. That was the first flaw. The second flaw was the mount point was supposed to disappear after the backup process, but it did not. Okay, that was a bug with the script, so this mount point was staying there the entire time, which exposed the entire backup folder system on the backup server to everyone who have access to this local machine. So the exposure was really, really bad because the local machine itself was not used to store anything useful. Okay, it was just a local machine, it's a client box for the most part, and nothing really important can be stolen, okay, because there was nothing important to begin with. But you know what? These other machines, one of these was actually running a MySQL server with employee ID, social security number, name of spouse, date of birth, and all of that stuff. Okay, and then the MySQL dump was backed up onto this machine. And now, because users on this machine can see everything in this mount point, and that mount point is corresponding to the entire folder of all the backup files, suddenly the exposure becomes everybody who have access to this particular machine. Am I explaining that okay so far? So it was a very bad exposure issue because the exposure is now backwards. So the question now is, how can we kind of avoid this type of problem of this type of exposure? Encryption? Well, encryption can help because if all the other machines only store encrypted files onto this server, you can definitely limit the exposure so that people who have access to this entire file system cannot see the actual content of the encrypted file. Okay. What about the authentication part? Which machine logs into which other machine? I would have the backup server to log into the client machine to backup. Because that way, the exposure is reversed. Okay? There's no one, nothing on this machine would know any password or any username to go back to the backup server. It is the exposure is reversed. Okay? And then the second thing is I don't even need to use Samba because I can combine SSH and GPG to do everything. So what I need to do, to do all that stuff, is to have the backup server to run the script to authenticate onto this client machine here to establish SSH. Once SSH can be established, I can run tar remotely on this machine and then go through GPG and then only store the GPG encrypted version of all of those files locally onto this server. So this way, even if someone hacks into the backup server itself and have access to all of these files, they're all encrypted. They can't even make out what is the actual content on the original machine because they're all going to be encrypted. But the transmission itself is going to be going through SSH, which is also another layer of encryption, which means people can sniff the traffic all day long, but they won't be able to see what is actually being transmitted. Are we doing okay so far with that example? So if anyone is interested, I can kind of show you the script to do all this stuff, how to pipe tar, GPG, and SSH to get all of this done on a single line. No, it's not. It's just, one command is doing one thing, and then the output of that command goes to something else, and so on. So you're basically just chaining all of these commands to do something that normally cannot be done with a single command. But that's the power of Linux, or the power of Unix type operating system, is because they're all file-based, and most things can be run on the command line. Because when you run something using a GUI, it's good. I mean, end users can do it very easily, but how do you automate it?
You should combine that with rsync too. You combine that with rsync.
Yep.
You're mentally back up. Well, not but
you can do rsync and also I was about to say unicorn, but it's not. Unison, okay, Unison, UNISON is a utility program, and Unison can synchronize files based on what files have changed only. So you can have like a file system with 10 gigabytes of pictures, okay, and then when you do a quote-unquote backup remotely, Unison can look through the files that have changed locally and only update those particular files remotely. So you don't have to send 10 gigabytes of stuff every single time.
Does it do that like an MD5 sum, or like if it's changed, or
yeah, it maintains some kind of checksum internally. It also looks at the creation date, modified date, and also in Windows, it might make use of the archive flag, but most programs don't use the archive flag for anything useful anymore. So it has its own quote-unquote way to find out whether a file has changed or whether it's created, whether it's deleted, and it will mirror the operation remotely. But because it only does the delta, so that means it is also very efficient, because if there's no change locally, or you just added one file, it would just transmit that one file over.
Well, it's efficient space-wise, but not so much processing-wise.
Processing-wise, MD5 checksum is relatively quick, so I think it has ways to do it pretty quickly. I use it to synchronize across multiple servers too, and it works pretty well. All right, so we are running out of time today. So when we come back after spring break, we will definitely have an exercise or homework on GPG itself, because it is a pretty useful concept, and I just think that it's really good to have an exercise on GPG. After that, we can go into ClamFS, to do virus checking, because that's also something that a client computer typically is exposed to. And then meanwhile, you guys should go home and change the passwords of all of the accounts that you have, on the internet. And I'm not kidding. That part, is actually.
That is true.
Yep.
I had a question for you.
Yep.
The entire class period, I've had virtual